Hi everybody. In this video we are gonna talk again about the PTAL project, and more in detail we are gonna talk about the details of the PTAL platform, and we will try to explain what kind of services this PTAL platform will do to all the kind of researchers that are working in the field of planetary exploration, and more in detail on the exploration of Mars. As I said in the previous video, the PTAL Terrestrial Analog Library is a project that's been funded by the European Commission through the Horizon 2020 program. And as I say also in the previous video, the reason of the PTAL project is to provide future users with an extended database of terrestrial analogs materials that has been selected based on their similarity to Martian geological context. So, in a few words, terrestrial analogs are locations on Earth which have characteristics that are quite similar to what we're expecting on Mars. So, on one side, we have, as you can see on the left image, we have location on Earth that have environmental conditions that are similar to Mars. This is in detail the picture of the Atacama Desert in Chile, and this is one of the driest places on Earth. So several researchers goes there, try to understand how microorganisms can live in such harsh conditions, and in this way try to obtain clues about how microorganisms could have lived or survived on Mars. Then on the other side, we have also places which are geological and mineralogical similar to what we can find on Mars. So thanks to previous missions, we found out that several locations on Mars has jarosite, which is a mineral compounds that only crystallize under specific conditions, which means when we have the presence of very acidic water rich on heavy metals. And there are just a few places on Earth that have conditions that match what we could have found on Mars a few billion years ago. And for example, the Rio Tinto in Spain. So several researchers go to Rio Tinto to select samples and try to understand if in these conditions there are formal life that can actually proliferate. So, of course, to reach those places is quite difficult. So to simplify the work of the researcher, what we are doing is to collect samples from those terrestrial analog sites, and then we provide them access to the scientific community. So back in 2016, the PTAL consortium, the people working the PTAL project, has been traveling around the world to collect several materials, several terrestrial analogs from different locations. And as you can see in these summarizing tables, at the beginning, the PTAL project included a total of 94 samples, which were organized in 12 different groups. So we have impact melt rocks, we have samples from the volcanoes in Canary Island. We have samples from Antarctica, from the Jaroso and Rio Tinto location in Spain, and so on. Now we do not have the time to go into details of all these samples, but what is important here to underline is that the description of all these samples is provided in a dedicated manuscript that is provided here below. So in this manuscript, you can get information about those locations and an explanation of why those terrestrial analog sites are considered to be analogs of Mars. Then during 2018 and 19, we added additional analogs that are quite similar to the geological units that we can find at the landing site that has been selected for the ExoMars mission, which is called Oxyaplanum. So, for example, we have those very interesting samples from Granby, and if you want, you can check this paper that describes those terrestrial analogs and explain why those materials are considered very similar to the phyllosilicate units that have been detected at Oxyaplanum. Then beside natural samples, what we have are also artificial samples that has been altered under controlled environmental conditions. So in this case, what we have been doing are experiments where we submit terrestrial rocks to environmental conditions that are the one that we expect that have been present on Mars in the past, and then we try to check the evolution of the alteration patterns, and through those information try to understand the past environmental condition and of Mars and its evolution through time. So we performed several experiments, and some of them have been recently published on this paper, which I suggest you to check it out. Regarding the analytical study of those materials, we follow the following workflow. So basically, all the samples, or most of the samples, being collected by our colleagues from the University of Oslo. They powder part of these samples, and they perform XRD analysis. Then those same powders have been sent to the University of Paris South, where our colleagues perform near analysis. Then the same powder has been sent to University of Valladolid in Spain, where we perform complementary Raman characterizations. And finally, the powder has been sent to IRAP, also in France, where they perform a Libs characterization. So we could also have elemental information about those materials. And one of the main characteristics of the PTAL project is that beside the use of commercial instruments, we also use systems that derive from present and forthcoming space missions to Mars. So, for example, for LIBS analysis, we use the ChemCam, the SPER model of the ChemCam instrument on board the Curiosity rover, which is still operating on Mars, while for NIR and Raman analysis, we use the SPER model of the Micromega and um, simulator of the RLS and the simulator of the SuperCam instruments on board the ExoMars and Mars 2020 rovers, respectively. Um, Now, the project is completed, so all the sample has been characterized and spectra have been interpreted. So what we did was to present scientific articles in which we summarize all the results we obtained. So, for example, if you want to check the Raman results obtained from all the collection of terrestrial analog from the PTAL project, you can check this article has been published in 2019. While if you are interested on checking the NIR data, we have actually two articles that you can check it out. So on one side, we have an article on the Planetary and Space Science Journal that present the results obtained by characterizing the samples with a commercial NIR instrument, while the second paper actually present the results obtained from the SPER model of the Micromega. Then what we did was to select the optimal spectra, and then we upload them to the PTAL platform. So as you can see here, there are just a few screenshots about the PTAL platform. So we have all the 106 terrestrial analogs with all the data that are related to these samples. So you can actually check the different materials, check the different results, and you can download you can either check the spectra online or to download them so you can open with your own software. As I said, those data are already included in the PTAL platform. So if you want to take a look at the PTAL platform, here is the link. While if you want to have more information about how to use the PTAL platform, I suggest you to use our YouTube tutorial that you can open through this link. Then, beside providing spectra, we also, through the PTAL platform, we also provide access to the Spec Pro software, which is a software that has been developed in the framework of the ExoMars project to open and visualize the spectra, Raman spectra from the RLS system. As you can see here, the software has been actualized so it could actually be used to open different kind of spectra, also near R and Libs spectra, for instance. And if you want to check how to download the Spectral software and how to use the Spectral tool, you can also check this tutorial that is also on YouTube, and you can access to it by clicking on this link. And to conclude, the PTAL, one of the main characteristics of the PTAL platform is that it provides access also to the physical samples. And that is very interesting because if you want to combine the spectra we provide in the PTAL platform with your own analytical data, so you can just request access to physical access to the samples, and we evaluate your request, and we send you a fragment of this material so you can perform your own complementary analysis and you can build your own research. So if you want to know how to request physical access to the PTAL samples, please check all the information that are contained on the PTAL platform, which you can access by clicking on this link. So on the behalf of the PTAL consortium, thank you very much for watching this video.